In this video, I'm gonna talk about linearization, how you can find the linearization of a function. Linearization of a function, and what does it actually mean? That's what I'm gonna cover in this video. Okay, so let's get started. Let's say we have function f of x, and let it be equal to cos x. Okay, and let's say we have this point that is a equal to pi over 2. Okay, so that a is equal to pi over 2 is just a point in the range a point in the domain of this function. Okay, now we need to find the linearization. So linearization follows a formula that says like this: L of x. So in order to find the linearization of this function, we have to apply this formula, and that is f of a plus f prime of a times x minus a. Okay, that is the formula that you need to follow or to use when finding the linearization of any function. So basically what linearization means is that we need to find a function, a linear function, that's gonna give us the same value that cos x will give us when x is equal to pi over 2. Okay, that's actually what it means. So first we have to find f of a and f of a is equal to f of pi over 2, which is equal to cos pi over 2. Okay, because our function is anyway x is cos, so it's gonna be cos pi over 2. So that gives us just cos pi over 2 is equal to 0. So next we will have to find f prime of a. Okay, we've already got this, we will go and find this. So f prime of a is equivalent to f prime of pi over 2. Okay, so first we have to find f prime of x before we could further find the value of that derivative at pi over 2. So f prime of x is just going to be the derivative of cos x, which is going to be minus sine x. So here we are going, our f prime of pi over 2 is going to be minus sine of pi over 2, which is equivalent to -1. Okay, we can now subtract, we can now remove this. Okay, now we have got all we need, so we can get our linearization, or our L of x. Okay, so our L of x would be our f of a, which is f of pi over 2, which is 0. So we're going to get 0. Then we are going to add it to our f prime of a, which is -1. So it's going to be plus -1. Okay, all of that we have to multiply with x minus a, which is pi over 2. Okay, so eventually what we're going to get is minus x plus pi over 2. So our L of x, our linearization, the linearization of these functions gives us this function. So minus x plus pi over 2 is a function that can give us an approximate value of of this function of f of x at a is equal to pi over 2. Now let me show you. We've already seen that cos pi over 2 here is giving us 0. How about this function that we just got, our L of x? So now we will just find our L of, since our x is going to be that point which is a, so we would L of pi over 2. Would it give us the same or approximate result that cos pi over 2 is giving us? So we can test that. Okay, we can test that. So now we have our L of x is minus x plus 2, right? So our x is pi over 2, so just take pi over 2, so it's going to be minus pi over 2 plus pi over 2, right? Because our function here is minus x plus pi over 2, so our x is going to be pi over 2, so it's going to be minus pi over 2 plus pi over 2, which gives us basically 0. So you see, this function that we just obtained, the linearization, through linearization, is also giving us a similar same result that f of x is giving us. Okay, let's take another example so that you can see better. Let's say we have this example, f of x, which is x cubed minus 2x plus 3. And let's say our a this time is going to be 2. Okay, let's find a function, a linear function that will give us the same result that f of x will give us when x is equal to 2. So that we have to use the formula that we have just learned in the previous example, that the linearization of a function can be obtained through f of a plus f prime of a multiplied by x minus a. So we have to find f of a. F of a is equal to f of 2. So we'll just insert 2 in the function here instead of x. So it's going to be 2 cubic minus 2 times 2 plus 3. Okay, so this gives us what? This eventually gives us 7. This gives us what? This gives us 7. Next, we are going to find f prime of a, which is equal to f prime of 2. So f prime of 2, in order to find f prime of 2, we have to find first f prime of x, or the derivative of the function. So the derivative of this function is obvious. It's going to be 3x squared minus 2, right? So we come here and we instead of this x here, we can put 2, because we want to find the derivative of that function at x is equal to 2. So it's going to be 3 times 2 squared minus 2. Okay, so this gives us 10. That gives us 10. Okay, maybe we can wrap this. Now we can find our L of x. Our L of x now would be simply bringing those together. So this is our f of a, and this is our f prime of a. So what we will have is bring them together. So our f of a is 7 plus f prime of a, which is 10, times x minus a, which is 2. A, which is 2. So that's gonna be 7 plus 10x minus 20. Okay. Okay, so that eventually gives us 10x minus 13. So this function that we got here, this L of x we have here is the function, is the linear function that can give us an approximate or a similar result that f of x will give us when a is equal to 2, when x is equal to 2. Already our function at 2 would be 7. Let's see if that L of 2 is going to give us the same result. Our L of 2, let's put instead of x we put 2. Let's see what that gives us. So we have already 10. So instead of x we will put 2 minus 13. Is that going to give us the same result that f of a has given us? Yes, it's going to give us 2, 7. Because 10 times 2 is 20, 20 minus 13 is 7. You see? So the function that we obtain through linearization can give us an approximate value of the original function at that specific point that we want to find. Graphically, I hope you can see. So this is our linear function. Is this long blue line? That is our linear function. And our other function is this one, okay? Is this one in green. You see at a point when x is equal to 2 here, if you see that they are giving us the same result, 7, which means that this function L of x can be used to approximate, this function L of x can be used to approximate this function at this point when x is equal to 2. Remember, you can't use this one to approximate the value of this function at all points in the domain. No, you can only use it at a specific point, like for our case here, when x is equal to 2. You can use it where the two functions are actually giving us the same thing. Okay? So, having said that, I'm gonna end this video, and in the next video I'm gonna talk about differential form, derivatives in differential form. So you may be interested to watch that too. Thank you for watching.